So, Ms. Avantika, unit vectors. Okay. So, before we start this concept of unit vectors, one thing that we need to understand is that maybe you will find the this theory of vectors a bit confusing at first. Yeah. And like other things in physics, other things in maths, till the time you do a lot of numericals, you won't be able to understand the concept. Do you see this playlist? 3D vectors, 11th, 12th.
Yeah, yeah,
So I've already sent one or two lectures to you. I'll be sending more lectures from this playlist only, because this playlist has lot of uh, practice problems. So, for example, if you see practice problems, practice problems, practice problems. So during the lecture, what I'll do is during this lecture, what I'll do is I'll just rush through the theory part, and then you'll have to do the numericals from the playlist. Is it okay?
yeah,
Okay. So to start, the easiest way to understand vectors is to imagine yourself to be in a room like this. So, for example, you are sitting in the room and you are, say, standing or sitting here on the corner of the room. Are we okay till here?
yeah.
This room that you are sitting in, just imagine that you are sitting in the corner of the room. Yeah.
Hmm. Yes,
So on the edge of the room, you have these three edges which are running. Do you see these three edges?
yeah,
So for example, if this is the base of the room, this edge can be called the x-axis, this edge can be called the y-axis, and this edge which is pointing towards the roof would be called the z-axis. Are we okay till here?
yeah,
The more you can imagine, the better the understanding of vectors would be. So I'll repeat, because that is how the things will start making sense to you. I'll repeat. This room where you are sitting is a cuboid, and you are sitting or standing here. This is running towards the x-axis. This is running
hmm.
towards the y-axis, and this is running towards the z-axis. Are we okay till here?
Yeah,
Now, just to give you a glimpse of what we will be dealing with, this room, are you able to imagine a rod which starts from here till here? Are you able to imagine this in space?
yeah, yeah,
Okay. Now I'll be building on this concept, and you have to stop wherever you feel uncomfortable. कि भाई ये मुझे समझ नहीं आ रहा. Yeah.
okay,
You'll have to
yeah,
stop me there and then.
yeah,
So let so again you are standing here. This is length. This is breadth. So on the ground, on the ground, this is L square plus B square ka under root. Are we okay till here?
hmm. Yeah,
So this is a right triangle. So if I
hmm.
see this right triangle, because the edge of the room have a 90-degree. So this line AC, because this is length, this is breadth. So this line AC is root A square plus B, L square plus B square. Are we comfortable till here?
Yeah,
Okay. Now just imagine. See this line, I'll reiterate, this line is on the floor, and it is joining this edge where you are standing with the diagonally opposite edge. Are we okay till here?
yeah,
Okay. Now the edge which is in front of you, the edge which is in front of you, that is the height of the wall. Are we okay till here?
yeah,
Now imagine this right triangle AC. Let me call this D. Are you able to imagine it?
yeah,
Okay. Now if you look carefully at this triangle ACD, then you have already calculated this AC to be L square plus B square. Are we okay till here?
yeah,
I know this is H. Are we okay till here?
yeah,
This rod AD, which you had kept in the room, which ran from one edge to the other edge. This rod is AD, and its length can be given by root of L square plus B square ka square plus H square is equal to root of L square plus B square plus H square. Avantika, are we comfortable with this fact or not?
Yeah.
You need to be very clear, and even if there is a 0.5% doubt, you need to stop me right now. Are we okay till here?
Yeah. Yeah. Yeah.
Now I'll reiterate whatever we have discussed till now. Yeah, just listen to me carefully and ask as many questions as you can if you have a doubt. I'm sorry. This is a this is where you are standing. Yeah, and this is L. This is B. First, I told you that this A B C that this AC is L square plus B square, and then I told you that if the CD is H, then if you have a rod, or another thing that you can do is, have you ever played with this laser which has this red light coming from it? Have you ever played with it?
Yeah.
So just take this laser in your hand and point it here. So this length AD is equal to root L square plus B square plus S square. Avantika, are we comfortable with this or not?
Yeah.
Okay. Okay. Now, there's another small thing that I need to, that usually is a doubt that I need to clarify right now. And of course, then we'll start with this. See, usually when teachers, and previously I also was teaching this vectors. So, we start, I also used to do this. I used to jump on this IJK. But then there are few issues if you directly jump into the fact of IJK. So that is why I'm spending some time on the introduction so that, you don't feel any problem. This is a cube of each side 1 centimeter. अवंतिका, are we clear?
Yes, sir.
मैडम, क्वेश्चन हो रहे हैं आपसे? अगर आपको एग्जांपल देख रहे हैं तो वो एग्जांपल सॉल्व कीजिए, उसको देखिए मत. आपको समझ आ गया? So this is one, this is one, this is one. Avantika, are we clear?
Yeah.
Okay. Again, that rod that I was talking about, that A, B, C, D. This rod, can you tell me the length of this rod in this cube? Would you be able to do that? Have you understood the question?
Yeah.
I'll repeat the question. Now the room in which you are standing is a cube of, side, say 1 meter, 1 meter, 1 meter. Are we clear till here?
Yeah.
There is a rod in the room which runs from where you are standing, which is here, to
Hmm.
the diagonally opposite point on the roof.
Hmm.
What is the length of side AD? Can you tell me the length of side AD?
It would be root L square plus B square plus X square, which would be yeah.
Shabash. Have you understood this?
Yeah. Yeah.
Okay. So one thing that you should never forget, and of course you will understand as we go deeper into vectors, is if there is a cube which is of if there is a cube whose each side is 1 unit, the length of the longest diagonal is root 3. It is not 1. Have you understood?
Yeah.
Okay. But now I'll ask another question. Now that is a bit tricky question. That is a bit tricky question. And if you are not able to understand, if you are not able to answer, it is absolutely okay because this one is a bit tricky. Avantika, let us assume that you are in a room now. You are in a room now where the length of the rod is actually 1 unit. Have you understood my question?
Yeah.
And I'm asking you, this of course is a cube, and now I'm asking you, what would be the each side of the cube? Have you understood the question?
Yeah.
The cube whose longest diagonal is 1.
Hmm.
What is the side of that particular cube?
It is tricky to answer this.
Okay. Now, this AD would be x square plus x square plus x square. Is it clear?
Yeah.
So basically, root 3 x square is 1. Are we clear?
Yeah.
So 3x square is equal to 1. X is equal to 1 by root 3. Avantika, have we understood this or not?
Yeah. Yeah.
If there is a doubt, please ask.
No. Yes, Samjha.
Pakka.
Yeah.
Let us check whether this answer is correct or not. So, imagine a cube whose each side is 1 by root 3. Are we clear, Avantika?
Yeah.
And if I have to find the length of AD, I'll have to use that same formula that I had written.
Yeah.
This would be Are we confident now?
Yeah.
So basically, I'm trying to tell you two things. And have some patience for 5 minutes and you will understand what I'm saying. I'm telling you two things, Avantika. If there is a cube whose each side is 1, then this longest diagonal, its length would be root 3. But if there is a cube whose each side is 1 by root 3, then its longest diagonal would be 1. Are we clear, Avantika?
Yes. Sir.
Okay. Now let us, once we have imagined this, now let us start what we started doing. Okay. Now, Avantika, this is a room where we are standing. Now, they have said that this floor is X, Z, and Y. Are you comfortable with this fact?
Yeah.
So, what we are trying to discuss is that, okay, I can call this uh, X, Y, Z. One second, I'll rather call it. This is how I'll call it. X, Y, Z. I can call this like X, Y, Z, or I can call it Z, X, Y. It is one and the same thing. Are we clear?
Yeah.
See, there is one thing that we need to understand. And right now, if you're not able to understand, it is absolutely okay. But down the line, we'll have to understand this. There is something called a right hand thumb rule. The first time you would have heard this rule was in class 10th when you were doing electromagnetism, when you were doing those AC motor. Do you remember? The motor and
Kind
the
of.
generator. Yeah, the motor and the
Huh. Huh.
generator. Then that time you would have heard about this right hand thumb rule.
Yes. Yes. Yes.
Okay.
The
You would have heard
the
this.
electric current,
Yes,
direction of
yes,
magnetic
yes, yes, yes.
field, and one more I
Fleming's,
forgot.
but no, that was Fleming's right hand thumb rule. Yeah, this is yeah Fleming's right hand thumb rule.
Thumb right hand
Yeah,
thumb rule.
yeah, yeah. So basically, what this rule approximately is saying is, I'll try to explain. Otherwise, it is easier to see it rather than explain it. So what you do is you take your right hand, your fingers are pointing towards this x direction, and then you close your hand in a fist. Your thumb should be pointing up. Are you able
Yeah.
to do that?
Yeah. Yeah.
So whenever you are doing these x's, your x's should follow that right hand thumb rule. That is all that we want. So for example, in this case also, if you take your right hand, if your fingers are pointing towards x-axis and you curl your finger towards this y, then you would see that your thumb is coming out of the laptop. Are we clear, Avantika?
Yes.
So the point that I'm trying to make is you can call anything x, anything y axis, anything z axis. All that you need to be sure is that whether that right hand thumb rule is being followed or not. Are we clear till here?
Yes.
Okay. Now, with all this introduction, now we'll come to the first thing that we need to understand in vectors. That is this terminology of I cap, J cap, K cap. It is called I cap, J cap,
Mm-hmm.
K cap. Are we clear?
Yeah.
Okay. Now, this I, J, K cap basically are called unit vectors. Why unit vectors? Because the length of this vector is 1 unit. Are we clear, Avantika?
Yes.
So basically, you can just imagine. Let me take this help of our cube again. You can just imagine like this, Avantika, that there is a cube let me call x, y. Let me call x, y, z. Yeah. Let me call this x-axis, this y-axis, this as z-axis. Are we okay, Avantika, till here?
Yeah.
So what I'm trying to tell you is that if this cube is 1 unit, this vector would be I cap, this vector would be j cap, and this vector would be k cap. Avantika, are we clear?
Yeah.
So this I cap, j cap, k cap. Are we clear?
Yes.
All that we need to understand is x points towards I points towards x, j points towards y, and k points towards z. Are we clear?
Yeah.
So this, in short, is the concept of a unit vector. Are we clear till here?
Yes.
Okay. Now I'll jump and try to explain. I'll take a jump and try to explain a bit tough concept, which would be tough for you right now. But after one or two lectures, that will be a very easy concept. So this is my x-axis, this is my y-axis, this is my z-axis. Are we clear?
Yeah.
See, don't worry much about the axis. So for example, I can call this x, this y, and this z also. It is absolutely fine. Are we clear, Avantika?
Yeah.
Or we see, end of the day, all that we need is that if we curl our fingers, right hand finger, the thumb should point towards the z-axis. Or if I'm curling my fingers from x to y. Have you understood the concept which I'm trying to tell you?
Yeah.
Okay. Now see what I'm doing and follow my path. So what I'll do is I'll move 2 units here. Is it okay?
Yeah.
Then I'll move 3 units here. Are you okay?
Yeah.
And then what I'll do is I'll move in space 4 units. Are you okay till here?
Yeah.
I'll repeat. First, I started from 0 or O. Let me call this O.
Yeah.
So I walked 2 units x-axis. Then I walked 3 units y-axis. And then I went into space 4 units in the z-axis. Are we okay till here?
Yes, sir.
Okay. Now there are 2 terminologies that I'll be using, and you need to ask doubt right there. The first thing that I'll be telling you is that, Ms. Avantika, this point is 2, 3, 4. Are you comfortable with this?
Yes.
Why can I call this 2, 3, 4? Because in class 10th, you have already understood that this is your xy axis. And if this point is 2, 3, basically what I mean is you have come 2 units here and you have gone up to 3 units here. Are we okay?
Yeah.
I am just extending the xy plane that you did in class 10th to xyz space. That is all that I am doing. Are we comfortable till here?
Yes.
So basically, with respect to this point, I am 2, 3. Right now, I am at point 2, 3, 4 in space. Mr. Vantika, are we clear or not?
Yes.
Mr. Vantika, there is a second thing that I'll be telling you. The second thing that I'll be telling you, that from my initial point, I am at a distance of 2 square plus 3 square plus 4 square units. Are we comfortable with this or not?
Yes.
So what I'm telling you is that I am root 29 units away from point O. Are we clear till here?
Yes.
This is the second point that I want to clarify. There is a third point that I want to clarify. From here to here, then from here to here, then from here to here. This whole process can be this final product, this net displacement can be written as, if this is point P, can be written as 2i plus 3j plus 4k. Are we comfortable with this or not?
Yes.
So this point P with respect to O can be written as a position vector. This OP is called a position vector. This is one thing. Are we clear?
Yes.
Another thing that you would have understood is, and you need to stop and ask me your doubt if there is a if there is any. So if I am given any random position vector, so for example, I'm given a position vector like if this is a random position vector that I'm given, and if I'm asked the length of OQ, this is how the length of OQ is asked, then I will be able to say that the length of OQ would be 9 plus 1 plus 16 is equal to root 26. This is one thing. Are we clear about this or not?
Yes.
Okay. Let us try to relate to theory whatever we have learned till now. So this symbol, this is called the magnitude of a vector. This is one thing. Are we okay?
Yes.
In class 9th, if you remember, you would have done vectors and they told you that vector is something which has magnitude as well as direction. Do you remember?
Yes.
So this magnitude is represented by this. Are we clear, Avantika?
Yes.
You can read this at leisure, but let us try to understand. Yeah, let us try to understand few other very basic things. Okay, the first basic thing that we need to understand is representation of a vector in terms of unit vector along the coordinate axis. So the easy way in which you can understand this is, again, if we take our vector in xy plane, when we take our vector in xy plane, this is the xy plane that you have been doing from class 8th, 9th, 10th. This is the same plane that you have been using. So
Hmm.
if there is any point in it, so for example, there is a point, let us assume xy. So this xy point would be x units here and y units here. Are we clear, Avantika?
Yes.
Do you agree that if I had to write what this OP vector is, do you agree that this can be
Hmm.
written as xi plus yj? Do you agree to this?
Yes.
Do you agree that length of OP vector would be given by root of x square plus y square? Do you agree to these two things?
Yes.
Similarly, if I had this same thing was being discussed in space, so if there was this random point in space which was x, y, z, x comma y comma z, then this OP vector could have been written as. Do you agree to this?
Yes.
Do you further agree that this OP, length of this OP would be x square plus y square plus z square? Do we agree to this?
Yes.
So, right now, what we have understood in the last 15-20 minutes is that, what is a unit vector? What is the basic concept of a unit vector? The second thing that we have learned is that, in how we extend our xy plane of class 10th to xyz plane of class 11th and 12th that we'll be using now. So this is what is called the 3D, the three dimensions, the XYZ dimensions. And what we have understood is that, if there is a point in space, there is a point in XYZ axis, how do I plot that point? Are we clear, Avantika, till here?
Yes.
And of course, like when we used to do this, if you remember, so if this was a XY plane, then say for example, this is 2, 3. Then I will have a point like this, which will be minus 2, 3. I would have a point like this, which would be minus 2, minus 3. And there would be another point, which would be 2, minus 3. Have you understood what I've said?
Yes.
Similarly, when we are talking about these cuboids, See, one would be a cuboid like this. So this is one cuboid. But then, yeah, this is the first cuboid. But then this can be extended like this also. Have you understood the point?
Yes.
So then there would be another like this also. Have you understood what I'm saying?
Yes.
It's like, when we stay in this the flat system, the Bombay flat system. So there are these flats
Hmm.
around you. So
Yes.
basically, what I'm trying to tell you is that if there is a point like 2, 3, 5, of course, there will be a point like 2, minus 3, 5. There will be a point like 2, 3, minus 5. There will be a point like minus 2, 3, 5, and so on. Have you understood what I've said?
Yes.
Just give me a second. I'll try to see if I can find a good photograph where I can show you this. 1 second. So basically, this is what I'm trying to tell you. Do you see this? Point and
Yes.
octant.
Just a
Do
second.
you see?
Yeah.
So this is what I'm trying to tell you. That, so for example, we had this xy plane where we had different points. So similarly, in xyz plane, we can have these different points. So for example, this is what I'm trying to say. So if this is x, this is y, this is z, then this would be minus x, this would be minus y, this would be minus z. And our point can be in any of these. Basically, these are 8 boxes, 4 boxes on the right hand side and 4 boxes on the left hand side. Are you able to imagine?
Yeah.
There are 4 boxes on the right side and 4 boxes on the left side. So this is how our so so this is what they are saying, that you can extend. So for example, in 2D we had only xy axis, and now we are extending this xy axis into xyz axis. And this is what I was trying to tell you about the right hand rule. Are we clear till here?
Yes, sir.
And see, this is what you will be using in when you start doing organic chemistry. There also you'll have to imagine these kind of shapes. Of course, in physics, in detail, it will be there. So this is what is called the xy plane, x and y plane. This is what is called the xz plane, and this is what is called the yz plane. So one thing, are we clear?
Yeah.
So till now, what we have done is we have extended our xy plane into xyz plane, and because the point is, this is like the path that I'm trying to take is, the easiest for a newbie. That is the path that I'm trying to take. Are we clear till here?
Yeah.
Okay. Now there is something called, so for example, okay, let us try to understand. So we are okay. This is how it is written: xi plus yz. So in 3 dimension, if I have x, y, z, I can write this as xi, y, j, z, k. Are we okay till here?
Yes.
I have also understood that the magnitude of the vector is x square plus y square root, and the magnitude of this vector in space is x square plus y square plus z square. Are we okay till here?
Yes.
Okay. So let's talk a bit about the angles also. This angle, that theta, in 2 dimensions, this angle theta, the tan of this angle is equal to perpendicular upon base. Are we clear?
Yes.
So this is what is being mentioned here. This tan theta is y by x. Okay. Now, when we come into this 3 dimension, there is a little bit of little, not much, but little bit of understanding that we need to have, that the angles alpha, beta, gamma are the angles that the diagonal, that the rod that we have kept in the room, that it makes with the x, y, and z axis. Let us try to understand this on this figure. Let me explain. Okay. So we have 3 angles: alpha, beta, gamma. Alpha angle is what this rod is making with the x-axis. So this would be the angle. Are you able to imagine it?
Yeah.
Angle beta is the angle that this rod is making with the y-axis. Are you able to imagine this?
Yes.
And angle gamma is the angle that this rod makes with the z axis. Are you able to visualize this?
Yes.
Okay. And then we may not use it much, but no harm in meeting a new concept. So cos alpha, cos beta, cos gamma, they are what are called the direction cosines. Direction cosines. We won't be meeting these concepts again. Class 12th. In class, the non-medical students do that in detail. But still, it's okay. These are called direction cosines, the cosines of the angle alpha, beta, and gamma. Are we clear?
Yes.
And whole of this, so if you don't understand this concept of direction cosine, it is absolutely okay. And whole of this cos alpha, cos beta, cos gamma are written as LMN. Are we clear till here?
Yeah.
Okay. So just spend 2 minutes trying to find the magnitude and direction of these vectors. Just spend 2 minutes.
Yeah.
So, for example, I want to have magnitude of this. It would be simply 3 square plus 4 square. Would it be 5 units? Are we okay? Avantika?
Yeah. Yeah, that I got.
Now, for finding the direction, let us try to see how this vector looks like. So, I'll be going 3 units here, 4 units here, and this is where the point would be. Are we clear, Avantika?
Yeah.
So, basically, this vector would be something like this vector. Are we okay?
Yes.
And what do I mean when I say that I want the direction? Basically, I want this angle theta. Are we clear, Avantika?
Okay. Yeah.
So, tan of theta is 4 by 3. Are we clear?
Yes.
And if you remember our trigonometry lessons, there is something called tan inverse we used to write. Do you remember?
Yes.
Let me take a very simple example. So, for example, if my let me write it like this. Let me take a very simple example. So, if somebody says that tan theta is 1, so therefore, theta would be tan inverse 1. Have you understood what I said?
Yes.
And I understand that this would be equal to 45 degree. Are we clear, Avantika?
Yes.
So, for example, if I take this fourth, then this is how the magnitude is written. The magnitude will be equal to root 3 square plus 1 square. Are we clear, Avantika?
Yeah.
This would be 3 plus 1. This would be 2. Are we clear?
Yes.
But if I want to have the tan theta, remember tan theta, if we refer to the formula, the tan theta is y by x. Do you see it here? And
Yes.
here our trigonometry lessons will be useful. That tan theta is y upon x. So minus 1 upon root 3. Are we clear, Avantika?
Yeah.
Now, and that is why I'm saying that now our trigonometry lessons will come into play. First thing I need to decide all sine, tan, cos. So this is negative. Minus 1 by root 3. So where is my tan negative? But actually, the better way of doing this question would be just to see where the vector lies. So this is positive and this is negative. So this is where my vector would be. Are we clear?
Yes.
This would be root 3 and this would be minus 1. Have you understood what I said?
Yes.
So this is where our tan is. Our tan is in fourth quadrant. Are we okay?
Hmm. Yeah.
So, I'm just taking a shortcut. So my theta would be tan inverse minus 1 by root 3. Are we clear till here?
Yeah.
And if I know a bit of trigonometry, then I can find my theta also. Are we clear?
Yeah.
I don't want to go into the details, but you would have got the drift. Are we clear?
Yeah.
Because मैं trigonometry में जाके उसको और confuse नहीं करना चाहता. So, but I hope you have understood what I said.
Yeah.
I've sent you this PDF. So this PDF would be with you. Now, the next topic that we need to understand is resolution of a vector. Now, this is very important. So, what does the resolution of a vector means? And Avantika, one thing that you'll always have to remember is that we would be, constantly working in 2 dimensions. So, there would be vectors which would be lying in 2 dimensions. So, this is how the vector would look like in 2 dimensions. And then there would be vectors which would be in 3 dimensions. Are we comfortable with both the dimensions? Have we understood?
Yes.
Yeah. So, just keep in mind that which kind of vector are you dealing with. So for example, just to clarify, so for example, this is what we were discussing. So this is some random point xyz, and this in space, this vector op. This is called the position vector. Why position vector? Because this is signifying a position of a point. So if it is in space, this is how it will look like. But if this vector, so this vector is in 3D, so that is why there is a I, j, k. And if there is some vector which is in plane, then you will see only a I and j. Have we understood what I have said?
Yes.
अरे भाई व्हाट्सएप तो नहीं चालू आपका? अगर व्हाट्सएप चालू है तो समझ नहीं आएगा.
No, it's my mom's phone, so somebody's calling.
अच्छा,
मैं साइड पे रखा है ना, in case you send something. That's बज रहा है वो तब से.
It is absolutely okay. एक तो see my point is, एक तो टॉपिक टेढ़ा है, तो अगर व्हाट्सएप चालू है तो बिल्कुल समझ नहीं आएगा. So if there is a vector like this 3i plus 4j, I need to be comfortable. I need to understand that this is a vector in 2 dimension. But if there is a vector like 3a plus 4j minus 5k, then I should be comfortable that this is a vector which is in 3 dimension. Are we clear?
Yes.
So for example, ये जो vector आपके सामने लिखा हुआ है, this vector, I should be comfortable that this vector is in 3 dimension. Are we clear?
Yes.
But if I see a vector like this, then I should be clear that this is in 2 dimension. Are we clear?
Yeah.
So resolution of vectors. So initially what I want to understand is that if there is a vector which is in 2 dimensions, so let me assume that this is point xy and this vector op can be written as xi plus yj. Are we clear what I have written here?
Yes.
Okay. Now let me say that this length x square plus y square, the length of this vector is equal to r. Are we clear, Avantika?
Yeah.
So now rather than writing every time root x square plus y square, root x square plus y square, I'm just writing it as r. Are we clear?
Yes.
So basically r is the magnitude of the vector op. Are we clear, Avantika?
Yeah.
Now what I want to do is I want to write OM in terms of r and theta. Have you understood what I've said?
Yeah.
Similarly, I want to write ON in terms of r and theta. It is pretty easy. Why? Because cos theta is base upon hypotenuse. Therefore, OM would be r cos theta, and sine theta is equal to perpendicular upon hypotenuse. Therefore, PM is equal to r, and PM is equal to ON. So ON can be written as r sine theta. Mr. Avantika, are we clear?
Yeah.
So therefore, this vector xi plus yj can also be written as r cos theta I plus r sine theta j. Mr. Avantika, are we comfortable with this fact or not?
Yes.
It's pretty easy. If you have understood till here, this concept is relatively easy. All I'm trying to tell you is, this is all that I'm trying to tell you, that one way of writing this vector is xi plus yj. This is one way of writing. But what I'm trying to tell you is there is another way of writing this. What I do is, I say that length of OP is equal to r. And this vector is making this angle theta with x-axis. Are we clear?
Yeah.
Another way of writing the same vector is r cos theta I plus r sine theta j. Are we clear? This would be r
Yes.
cos theta. This would be r sine theta. Are we clear till here?
Yes.
So what I have done is, basically, Avantika, in vector notation, what I've done is, let us try to understand what I've done. In vector notation, I have resolved this vector OP into its component. One component is this one, and another component is this one. Mr. Avantika, is it making sense or not?
Yes.
Let us relook this, what I'm trying to say here. If this vector is r cos theta I, and this vector is r sin theta j. If I add these two vectors, I will get this vector, which would be r cos theta I cap plus r sin theta j cap. Ms. Avantika, is it making sense?
Yes.
So this is the format in which it is written. This is important, and what you will need to do as homework would be, what you need to do is, one second. Yeah. 22. See, this next page is faded. I'll show you. This is 22. This next page, 23, is faded. So what you'll have to do is, you'll have to go a bit further. 24, 25, 26. Yeah, here you will get 23. Have you understood?
Yeah.
So your homework would be, it will be good if you are able to practice. Try to do this example 10.18.
Okay.
You can refer to the answers. I'll explain it to you what they are trying to say. So they have drawn few vectors here. So do you see A vector, B vector, C vector, D vector, E vector, F vector, G vector, H vector? Yeah. So what they are saying is,
Yes.
find the components of the following vectors. So for example, if there is a vector like say B, so B makes an angle of 37 degree with x-axis, and length of B is 3 units. Basically, this length is r, and this theta is 37 degree. So all they are asking me r cos theta and r sin theta. Have you understood what I said?
Yes.
A simple answer would be 3 cos 37 degree and 3 sin 37 degree. Have you understood what I said?
Yes, sir.
So these are the two components. You need not find the value of cos 37, but the point is you should be able to understand this question. What are they trying to say in this question? You can look at the solutions also. That is not an issue. Just go through this.
Okay.
If you are able to do this, it would be good, because next time we will start with this polygon law of vector addition. We will try to do few. This is what we were discussing now, position vector. You see this? This is what we were discussing now. And we'll try to understand what is this displacement vector. And then we'll come to the product of the two vectors. Now, I just want to link whole of this with your syllabus. So, if you see, this is how your syllabus looks like. Unit vector, resolution of vector in a plane, rectangular component, scalar and vector product. This is where we are. Do you see?
Yeah.
So if you read this unit vectors, if you read this this parallelogram, this is what we will be doing the next time. This is what we are discussing, rectangular components. And this is what we will be finally going to, the dot and the cross product. Have you understood? So all this is part of your motion in a plane. Mr. Avantika, are we clear? Mr. Avantika, are we clear?
Yes. Sorry, I didn't know. I was on.
Yeah. It's okay. So let's meet tomorrow, same time. Fine. Yeah.
Yeah.
Okay. So your homework is the questions that I had mentioned today and the lectures that I had sent yesterday. Maybe I think 1 or 2 lectures are there. Yeah. Let's meet tomorrow. Yeah.
Yes. Thanks.